Okay, let's look at another example here of solving right triangles. So it asks us to find the unknown measures and to round the lengths to the nearest hundredth and the angle measures to the nearest degree. Okay, lots of ways that we can start, guys, using trig ratios here. Really not a ton of well, there are a ton of wrong answers, but not wrong ways to go about the problem using trig ratios, right? So the first thing I'm going to do maybe is find the measure of angle D just using the triangle sum theorem, or the fact that the acute angles of a right triangle are complementary, right? So I'm going to write that out again. I'm just going to say the acute angles of a right triangle are complementary, right? So I can take basically 90 minus 58. Sorry about that, that's a 2. Okay, 90 minus 58, and that's going to give me 32 degrees for D. So 32 degrees equals the measure of angle D. Okay, and I'm just going to write that in here in green just so we know kind of how I got that work. Okay, all right, well, again, lots of ways I could go about this. Maybe I'll look at this problem in the context of angle F. Okay, well, angle F, if I want to know, maybe I'm trying to figure out EF. So EF would be the adjacent leg here, and ED would be the opposite leg. So if I look back at my ratios, if I look back at SO, CA, TOA, right, what I just highlighted in blue there was an adjacent leg and an opposite leg. So this is kind of what I'm looking at, is TOA, right? So I'm going to take the tangent of 58 degrees, okay, and that is going to now give me, let's say maybe 14 over EF, right? So it's opposite over adjacent, so that's going to give me 14 over the measurement of EF, okay, and I could multiply both sides by EF here, okay. And we're kind of doing just what we did in the previous lesson now. Now I have EF times the tangent of 58 degrees, and that's going to give me 14. And I can divide both sides by the tangent of 58 degrees. Okay. Oops. Divide by the tangent of 58 degrees. Okay, and those will cross out, and I'll end up getting that EF equals, and again, I got to go back to my calculator here, so let's figure out 14 divided by 58 tangent, and that gives me about 1.60. That was what I actually get here. So I'm going to write 1.60, or just 1.6 for EF, right? So I get, again, 1.6. And I want to find the hypotenuse here, right? 1.6 doesn't seem right there. I'm going to try that again. So 14 divided by the 58 tangent. Okay, sorry about that. I forgot to press equals. My apologies. I must be kind of tired or something. I get about 8.75 there. I was going to say, I look back at my diagram there, and that number just did not really make sense to me. So I'm glad I caught that. Okay, so this is again 8.75 here. Okay, and now I want to go and find the hypotenuse, right? And so there's, again, lots of different ways we could go about finding the hypotenuse. We could use the Pythagorean theorem, but maybe, in the spirit of the fact that we're learning inverse trig functions, maybe we'll take a look at some inverse trig functions here. But wait, we can't, right? That's kind of the point. We use the inverse trig functions or to find the angle measurements, but we already have all the angle measurements. All right, so in this case, I'm just going to go ahead and use the Pythagorean theorem, right? So I'm just going to say that 8.75 squared plus 14 squared is going to be equal to FD squared. Okay, so 8.75 squared is going to give me 76.5625 plus 14 squared is going to give me 196, and that's going to be equal to FD squared. Okay, if I add up 196 plus 76.5625, that gives me 272.5625 equals FD squared, and I'll take the square root of both sides to find out that FD is going to give us, it looks like 16.51. Okay, so again, on this particular example, I didn't even really use any inverse trig ratios because I didn't really have to, okay, because they gave me one acute angle measurement there, okay. Again, I hope this extra example is helpful and that you guys feel confident to go ahead and try some problems on your own.